Hello, my name is Dan Stowell. Thank you for having me. I'm very pleased to be invited to take part in this. The Open Data Institute is a really cool thing. And of course, it's great to be working on the climate crisis. So I'm going to be talking about something which is a collaboration. I'm an academic, I work on machine learning, but what I'm talking about today is a collaboration involving the Alan Turing Institute and OpenClimateFix. And this is also Openstreetmap community as well, as you'll see. So working with motivations of OpenClimateFix, of course, we want to assist with the climate crisis, and one goal is to burn less fossil fuel in the nation's spinning reserve for energy, electricity provision. And in order to do that, we need good solar power predictions of the fluctuations in solar panels on people's roofs. To do that, we need cloud cover forecasts, and we also need the exact locations of those solar panels. Much more detail about this on openclimatefix.org. But what I'm going to talk about today is exactly this in the lower region. We're looking to find the geolocations. And there is official data, of course. The UK is pretty good at open data on this. There's the feed-in tariff, the planning database. Lots of stories we could tell about those. The main thing to bear in mind is that the geolocations are often approximate because these things are postcodes or other kind of sometimes anonymized or privacy modified data, so we don't have exact geolocations. We have great coverage of large-scale solar farms, but a lot less cover of small scale. And what we wanted to do, what I've been involved in for a long time, in fact, is OpenStreetMap. Of course, it's the Wikipedia of maps, so we often say. Anyone can edit it, and as a result, it's better than commercial maps. It's used by many, many different industry and other providers. If you look at OpenStreetMap, in fact, if you look at this beautiful rendering from Open Infrastructure Map, or openinframap.org, so you can see that, in fact, people who are keen on this sort of thing have already mapped into OpenStreetMap a lot of the energy infrastructure of our country and various countries. So there's some really cool data there already. It tells us something about the network. And in my previous work, I've volunteered plenty with crowdsourcing work where we are looking to map buildings and roads in the global south to help with humanitarian initiatives. And what we do often is volunteers, you can see them in the picture, they scan through aerial imagery, they're looking for buildings, they're looking for villages, and they do a kind of skeleton map of a particular place, and then locals can come along later and fill in the details. So it's a sort of very remote collaboration. So we wanted to do that, but with solar farms. And now it's solar farms and small scale. And we're talking about the UK here. So our initiative was just for the UK. You can see solar farms on the left there. Okay, about 2/3 of the UK's solar energy electricity capacity is solar farms, and that's great, and they're relatively easy to spot. So you can see the image there, you could see it from space, and it's quite distinctive. But small scale, that's 1/3 of the provision and probably going up as we speak. And but because it provides a non-trivial amount of capacity and also quite a lot of variability, it's important to capture that as well. We can't rely only on knowing about the large farms. So within OpenStreetMap UK, we started a quarterly project. So I want to just pause and emphasize that this is not just about building a data set. This is a community initiative, and OpenStreetMap, people who are part of OpenStreetMap know that it's not just about building a map or building a data set. Community is important, especially for constant updating of data, and not just to get the thing done, but also to be stewards of the data going forward. And in OpenStreetMap UK, we have this quarterly project pattern of activities. And so in 2019, we decided to do solar power for the UK. that's one part of what happened. So now this plot is some work that we did within OpenClimateFix, sort of a little bit separately or afterwards. So within OpenStreetMap, we're getting community edits to the data. We're doing a lot of work here. But we are also within a project which was OpenClimateFix and the Alan Turing Institute. We were going through that data, doing some data merging with official sources, deduplication, all of this kind of thing. So our goal was to produce a good, cleaned up, rich data snapshot. And as we were going through this, we'd go through a sort of iterative process of feeding back, editing our rules, feeding back to the OpenStreetMap community about which tags we wanted and so on. So there's a lot of community iterative cycle in here. And so throughout this quarterly project, the quarterly project started in summer of 2019, and then we've made some great progress. People all around the UK, their local solar panels that they would spot in the street, but also looking at aerial imagery. And then this happened, and this came from a handful of ace individuals who really put some effort in to get over 100,000 solar panels mapped in the UK. And that was in the quarterly project. In fact, it didn't stop there. So it continued, and it continued into 2020. And then as we had some lockdowns in 2020, one thing that happened was during that summer, there was another burst of activity. So we really got a long way. I haven't checked actually the latest number, but I think we're over 300,000 solar panels, separate objects mapped. So thanks to those mappers, thanks to the community that didn't just do things, but also shaped the project. And of course, OpenClimateFix was also instrumental in doing this and working this through. The workflow, this is something that I would emphasize the workflow. There is a lot going on inside this arrow here representing the OpenStreetMap community, but also as a slightly more formal project run by a funded project at an institution, it's useful to be sort of actually connecting up with these projects. So to conclude, yes, we've obtained precise latitude, longitude locations for over 260,000 solar PV installations in the UK. The data is there. You can see there's a Nodo link, and that is for the snapshot that we officially exported when we'd finished it. Now, OpenStreetMap, of course, is this worldwide database where more solar panels are being added as every day, let's imagine. But what you see on that Zenodo link is the sort of official stable snapshot that we produced. It's often useful for a lot of data consumers to have a snapshot that's been sort of, well, firstly grabbed and fixed, and then also sort of cleaned up and maybe verified and validated. There's the code there also that we use to do that post-processing of the OpenStreetMap data. There's a lot we want to do with this. So OpenClimateFix, that data is going directly into the solar energy prediction workflow that I mentioned at the start. We're also interested in machine vision, so using this data to help maybe train a classifier detector of solar panels that could be applied to get the missing ones or to be applied in different countries. It would be great to go global with this. So small-scale PV, photovoltaic, is a particularly valuable missing piece of the picture in terms of the open sort of data infrastructure. We have some data, but it's not complete. And as you do this, just remember the importance of community. I think some of what we've done here could, I hope, be of interest to some people working in different countries. Of course, the situation is going to be very different, and in particular, the OpenStreetMap community might be very different. You might have a large number of people ready to go, or you might have to do some work building up that community. Either way, seems to be a pretty good way to go. Thank you for your time.